When you're designing your dream home, you may be thinking about the kitchen layout, big windows, or even lighting design. But what about the things you don't see? In today's episode, we talked about what's hiding behind the walls, systems, and why planning for them early matters. The idea of shoehorning systems into houses, remodels and new, is really frustrating. You know, if we can, we want them to be integrated well. There's all different kinds of problems with this. There's the effect that has on design or layout. It encroaches on other spaces. It feels tacked on. There's coordination problems for other disciplines. For the client interface, sometimes it feels clunky. It makes installation and future service difficult. And so we kind of want to just introduce the topic to help our clients understand the big categories, the complexity of problems, the necessity of experts, and the importance of communicating their design goals and priorities early. And I think just to cut to the chase, the solution is to get the right people on board early.
That's right.
Yeah.
And so the framework for today, I think, is MEP, which is mechanical or HVAC systems, electrical, plumbing, and then AV or like anything that involves automation or kind of like low voltage stuff.
Integration and control. That's right.
Right. So just to start us off, I have a broad question. At what stage of a project should homeowners start planning for these types of systems?
Early. Very early.
How early?
Yeah.
Oh, I think that part of the programmatic approach that most architects take is a long list of questions or feedback that they need from a client, asking the client what their expectations are of the home and how they expect to live in it, how they expect it to perform. And that will begin to inform the design team what systems are going to be needed to make it achieve that.
Right.
And I'm sure the topic is so complex and the options are so many that we can't cover it all today, but I think it's important that we explain the fundamentals of each of those systems and how they interact with each other and the kind of spaces and positions that they need to be in for them to perform and be accessible, serviceable, functional.
Yeah. Those things. I think to answer your question, like it should be a part of the conversation from the beginning, like you said, your people's lifestyle and how they expect to use the home. But it doesn't necessarily have to be really built into schematic design. It's when we get into the particulars of design development, then we need to really consider those things at that point. But certainly before we begin construction and at construction documents, we should have all of those answers at that point. Like, what are the things that people want in their home, and what does the home require in regards to some of those other systems,
right? And how they want to interact with it.
Yeah.
You know, I think the first and like one of the biggest things is like mechanical systems or HVAC. I remember very distinctly in school, the professors would get so annoyed with us because the program would always include mechanical space, and it would be a percentage of the overall floor area. And a lot of us, myself included, would basically have a big box somewhere in the corner, like a room of like, I don't know how to deal with this. I don't know what goes inside of here.
Yeah.
But here you go. I like check the box. I'm curious because I think we deal, especially with retrofit situations, but what are some things to consider for where like those mechanical closets might be located or where the equipment is?
Most systems perform well in conditioned space. I hate to show my age, but 40 or 50 years ago, we had a 3x3 closet and it had an air conditioning air handler inside of it, a furnace, if you will.
Like an upflow unit.
Right. There was an upflow unit somewhere in a hallway somewhere. But oftentimes it was in an attic. an unconditioned attic, and all the ductwork was in the attic, and the unit was in the attic. And here in Central Texas, temperatures get in the attic to 130, 140 degrees. And you're trying to cool a house down to 75 degrees in the summertime, so that a very inefficient location for that equipment and hard for people to get up in the attic and service it. And I think we're learning more about what makes the serviceability and performance work better in different locations and how to put it all in conditioned space. So I think today we do a pretty good job of achieving placing all those equipment pieces and components in the right space. It's a matter of, is there enough space, and are they centrally located where they service the home well?
Yeah, I think, the first thing that we do is traditionally we insulate our attic spaces.
Right.
So we still make use of the attic space.
Right.
But if you've got a 2-story home or a different kind of layout or flat or a low-pitched roof, that's not the case. So, we need to have some placeholders that are, like you said, centrally located, but, engage a mechanical engineer to help with the duct layout. But we need to be considering not just where does the unit go, but how do we distribute the air from that location? And where are we going to be distributing it to? Are there going to be multiple of these mechanical closets? And then also if we are going between floors, do we have an area, a chase area, where we can run ductwork up to the next floor? And, the sizing on that is very important. Obviously, you don't want to give up more space than is necessary, but you don't want to limit or reduce the performance of your systems because you didn't allow enough space for it.
Yeah. I think that's a common struggle between engineers that consider trying to place and size things, components, where they perform the best and are easiest to get to, and the design professionals who are trying to make the design elegant and not place things where they're obviously unattractive, if you will.
Right.
And so that's a struggle that generally comes out best when both professionals get to interact with each other during a design phase and yield the best outcome between form and function.
Yeah, and like you said, early enough to where, the floor plan is not totally baked and the homeowner is
there's still
happy
some
with everything
flexibility.
that's in there. If it's too late at that point.
Right.
But when it's just schematic design and you have some general idea, that's too early,
Yeah.
to know where those things are going to go. But at least, we've seen a recent feasibility study where they have, kind of sectioned off square footage amounts for bedrooms and kitchens and things like that, and including an area in there for mechanical or AV closets.
Yeah.
So which I thought was really awesome that they did that.
Yeah, for sure. I'm wondering what other indoor air quality related items do we need to accommodate, and how do they interact with the system, or I don't know. It could be a lot of different things. I'll leave it open.
Yeah.
Good question.
Well, yeah, definitely. The way that we typically install those things, they're in the same place or very close to the same place. Part of that, I think, is function because they sort of share ductwork sometimes, but also too serviceability. If somebody is servicing 3 different things, like if it's an air handler, it's a dehumidifier, and it's an ERV, they can do it all in one spot, and they're not having to climb around to get
that's
to
a good
those
point.
things.
Yeah.
Which that's another consideration when it comes to the size of the space is,
For sure.
can someone service it? Can you pull out an air filter? We did a project where we were very, very limited on space, and we had those pancake units in a drop-down ceiling. And, we had to make our accesses large, but we wanted to make them as small as possible. So literally in the framing stage, as we framed, we practiced taking the filters out to see if it was possible.
Oh, that's cool.
And not wait until it was
Yeah.
too late, right, to say, hey, we can't get these in or out. Now, it wasn't easy because we were trying to limit the amount of space, but we made sure that it was doable in a way that was, not going to prohibit somebody from servicing their machines.
Yeah.
Right.
Yeah.
I want to step back a second and speak to what you guys are talking about, indoor air quality components, because a lot of people, they haven't built a home in a long time, don't understand that in today's high performance homes, we control the air a lot more than we used to. All we were worried about is cooling or heating it.
Yeah.
Right? And because the houses were so open and airy that they just naturally breathe to the outside, whatever pollutants were outside were always part of the indoor air environment, and we just lived with it. And we had an inexpensive filter that was integrated with the system, and basically all it did is filter out some dust.
Yeah.
But we've since discovered that people don't respond well and are allergic to a lot of other indoor air pollutants that need to be removed from the indoor air space, as well as the humidity that builds up because people shower and they cook and they breathe.
Yeah, and the homes we build are much tighter now. So,
That's right. And so alongside all the quote unquote air conditioning equipment, heating and cooling equipment, as you said, we have to filter the air. We have to bring in outside fresh air. We have to dehumidify the air. And all the components that go to do that take up more space. It's not just a matter of accommodating an air handler anymore.
Right.
We need 2 or 3 times that much space to accommodate all those other components as well. And we also control air that we intentionally vent, like from bathrooms and from kitchen vent hoods. When we exhaust that air out of the house, the air that makes up what we pull out has to be filtered as it comes back in. So that's a controlled source of bringing in outside air. Those components have to be concealed in spaces as well. So, and again, they all have to be serviced over time. So it's a much more complex formula than it used to be.
Yeah.
And that's why it takes input from a number of different professionals during design.
Yeah. I think also something that is a major consideration and something that we spend a great deal of time working through, once we have this sort of layout and we have, the idea of where mechanicals are going and where ducts are going, then we work with the structural engineer and have to determine, all right, are there any intersections of ductwork and structural members that needed to be accounted for? And so that may change the layout, that may change the sizing of certain things, because especially in some of the modern homes that we build that have flat roofs or very limited space and big, wide open areas with limited interior walls to hold things up, we are sometimes going through steel beams or steel beams. Yeah.
That's right. That's the right word.
Steel beams to get ductwork to other areas of the house.
Right.
And that all needs to be done early on.
When you don't think about it and plan for it as an integral part of the design, you end up accommodating all those duct runs and equipment needs with scabs, what we used to call fur downs.
Yeah.
These boxes that are added on to the interior.
Parasitic to the architecture.
Yeah.
I'll pass on that.
So for ducts to run in and for registers to run in and equipment to live in. And it's just detrimental to the overall design. So again, it's great to have not just the equipment located during design, but the distribution, as you said, of all of that equipment integrated into the design, so we can see where those obstacles are and overcome them in the design phase instead of having to retrofit something during the construction phase.
Right.
Yeah.
And even thinking about details as simple as like return air, like, and grills and all of the little like trim type pieces. Sometimes you see something in a main space and it just feels like such an afterthought.
Yeah.
And if you can plan for something where you don't have to look at it, you don't have to hear it.
Yeah. But it still works well.
Right. Yeah. It kind of made me think of a project we recently finished where there's like a perforated brick wall. You don't even know that there's like another layer back there. And I don't even know exactly like the details of how that got worked out or if it just was like a solution. I don't know if you do either.
Yeah. So we basically we did essentially build what is a return box behind the wall before it was bricked, sealed that up so that it acted as the return.
Okay.
But it was more just that
Just like a
architectural
pattern
element.
of openings in the brick.
Yeah.
And it's cool because you wouldn't know if you didn't.
And that was done out of necessity because it was a very small space, and we really only had one wall to introduce conditioned air and then take out air at the same place. And so we have done that, which I think that's
It's
a pretty
successful.
cool idea.
Yeah, I think a lot of these features we're talking about can be integrated well into the architecture. Emma just finished a job that has a very unique walnut paneled wall, very similar with slats like we have here, and the return air plenum for the air conditioning unit, which was right behind there, was integrated behind that paneling.
Yeah.
You don't even see it.
Oh,
You
cool.
can't even.
I didn't know that.
You can't even detect it's there.
Nice. I
Yeah.
love that.
Yeah.
It's really like I think it kind of speaks to like if the architects and interior designers have the right information to design with, there's a lot of freedom to be creative because they have a better understanding of what they're working with and what it has to accomplish.
Yeah.
There's no better feeling than to overcome a mechanical structural obstacle with an elegant,
Oh yeah.
creative
Yeah.
solution.
Yeah. It's really rewarding.
Yeah.
What about ugly thermostats? What do we do with that? What do we do with that?
Man, I saw this like Instagram reel the other day about, and it like, I actually think I might do something like this at my own house because the thermostat is like right in the middle of this hallway. That's like, I don't want to look at that, where they made this little like tiny piece of art that like went around it. And it's kind of made me laugh because it's like, actually those are ugly.
Yeah.
Yeah.
I think in a very short period of time, because we're already beginning to see it,
For sure.
things like thermostats and humidistats and light switches will eventually go away. And we'll just have hidden sensors
Yeah.
Yeah.
that sense whatever they need to, and everything will be controlled on our phone or our television. And the actual brain will be located remotely.
Yeah.
Yeah.
And we do that a lot where we have
Right.
sensors, and the thermostats still exist and they're still there. They're just less visible and they don't necessarily have to be in the spot.
Right.
But there are very few good looking thermostats.
I know. Yeah, that's funny. What about, I'm wondering, just like common mistakes that we see when owners or maybe like a design team that doesn't have the right consultants, like what have we seen in the way of mechanical systems that are like, man, we could have fixed that if we had known ahead of time?
Yeah, well, we have one project that we're working on right now that the design team didn't bring a mechanical engineer in to design and lay out the systems. And we're struggling trying to find, I think Daniel has come up with some great solutions with the project manager, but it's a struggle to figure out elegant ways to get and route all of that equipment if it hasn't been thought through before design. Whether it'll perform as well as it should have or could have, it will be. We'll see once it's finished. But mechanical design is fairly simple for a given home oriented on a lot with the sunshine and the heat in a certain direction. It needs a certain amount of airflow into each room. It's pretty simple math, actually. And so the volume of air that goes into any given room is a function of the size of the duct that comes off of the air handler. And being able to get the right size duct to the right location means having to have passageways or openings large enough to do that. And if there's restrictions for solid steel beams or solid wood beams that are in the way or in the route, it's going to be hard to get it there.
Yeah. Well, you mentioned fur downs. I mean, that's kind of the last resort, but it
Yeah.
serves a purpose
Yeah.
sometimes. Like
Or maybe if you can creatively work them in where it
Yeah.
doesn't feel like an afterthought.
the other thing that, sometimes happens in those situations is when you use a ductless mini split that's got a wall mounted head on it. If there is no other way to get air to that space, then you can still condition it. which, happens sometimes.
Yeah, I would encourage our air conditioning manufacturers, if they're listening, to design a wall-mounted unit that's attractive.
Yeah.
Please, yeah. And maybe
nice.
not with like curved corners, just
Yeah.
make it look sharp.
Yeah.
There was one we saw not too long ago that was fairly elegant
Yeah.
looking. It was
They're getting
a
better.
rectangular box, but it looked better. But that will come. Ideally, as everyone sort of is beginning to see, ductless systems work better for specific. If you have a ductless system in each space of the home, you can't have a better conditioning system than that. Obviously, it has to be combined with other components in the house to dehumidify and ventilate, but it does a great job of maintaining temperature.
Yeah. That reminded me of another consideration that needs to be taken into account, and that's your condensate lines. Those machines, they create water, and that water has to be evacuated. Mm-hmm. And sometimes we run into situations where things are located such that it's very difficult to gravity drain something away. You want to keep the system as simple as possible and as maintenance-free as possible. So as short a down and out as you can get is the best. But sometimes,
Is there an example like you could give of like a difficult situation that's a more complex solution that's not really the preferred option?
well, sometimes something that I don't like that we often have to do or is often done is they are routed into a sink line. Mm-hmm. And there's a lot of stuff happening underneath that sink. Sometimes it doesn't matter because it's a utility sink or whatever, but sometimes it's in a more, decorative, say, a bathroom that has very pretty cabinets. Mm-hmm. And having to do that underneath those, I think it just kind of, once you open that cabinet door and you're like, oh, that's disappointing.
Yeah.
But, that was maybe thought through in the engineering and the design of it from a functional standpoint, but maybe not thought through in the aesthetic of it all.
Yeah, for the user.
Yeah, for the user.
Right. When we try to place air conditioning equipment that creates condensate, because part of the process of cooling air is to knock the water out of it, we got to get that water out somehow. And if it can't drain to a sink and it can't gravity feed to the outside, then it's going to fall to the bottom of the closet or space that the air conditioning equipment is in, and then it has to be pumped out. And the challenge there is that those pumps that sense when the condensate level gets up high enough and gets pumped, turns on, pumps out periodically, eventually they wear out, and and you have run the risk of a leak. Mm-hmm. And located in the central location of a house, if you have an overflow from a condensate drain line, it very quickly damages flooring and trim and paneling and sheetrock. So obviously placing those in an area where they can gravity feed is a much more optimum solution.
Yeah. To that, though, another consideration is if you are either put in that position or otherwise want to just have some insurance, is we often put in floor drains in mechanical rooms where, there are pipes and condensate lines and things like that. If there is a failure, at least it will still drain out of the house. Right. But those two need to be maintained as well. And
right. And they need to be planned for early in the design phase.
Yeah, if it's going through a concrete slab, you need to know about that pretty early.
I want to touch a little bit on the other components other than mechanical.
Yeah. Before we do, real quick, one more thing. Mm-hmm. What about range hoods? One little quick thing I have from a design perspective is I really just dislike breaking up an island with a range. And that's just like a personal preference, but also it creates it's more difficult, I think, to effectively get a range hood that's going to actually get rid of what you want to get rid of.
Very much so.
But I wonder, are there any other considerations that we might want to?
Oh, 100%. I mean, if you have a tight, well-built, high-performing home and you have a range hood, you need makeup air. Yeah. And you have to plan for that and provide space for that to work. Also space for it to be serviced. So for sure, I mean, we put, I think
this is kind of obvious, but just in case someone's not aware, if we're sucking out air, we're going to be creating negative pressure. We've got to add air back in.
Yeah. Right. Yeah. Thank you. Absolutely. But I think pretty much every home that we build now has some sort of makeup air system included in that.
For sure.
And, where that makeup air is brought into the home is a consideration. You don't necessarily want to see or hear it. But also the way that those work is they kick on when the range hood gets turned on. So those two have to be able to talk to each other. And I forget what it's called, but typically the wire is wrapped around, what is that thing called, that senses the
Voltage
current
sensor.
Yeah, the current flow.
Sensor, yeah.
And so
Current sensor, excuse me.
you have to be able to
Oh,
get the
interesting.
wire, the electrical wire from the range hood to that unit.
We used to have to make them from scratch. They were just little sensing boards.
Yeah.
Yeah.
I'm sorry, that sounds so funny.
Yeah, it does. But we did.
Pioneer, he's a pioneer.
When he had to walk to school 3 miles in the rain.
Now, this wasn't long ago, 5-6 years ago. We were
wow.
making these little boards that we ran the wiring for the vent hood through this board, and it sensed when the range hood was drawing current. And then it opened through a transformer, a low voltage damper to the outside that would let fresh air come in as the range hood drew it into the house.
Yeah.
Makes sense.
Yeah.
Nice.
Worked great.
I've also put in sensors that actually live inside of the exhaust pipe from the range hood, and it senses a pressure differential,
Oh,
and then
yeah.
it switches on the makeup air system that way.
There are several manufacturers who make kits with all those components integral to the kit. And you just integrate the wiring together, put in the ductwork, and they work simultaneously.
I think this is a topic for another podcast.
Yeah, I know, right?
Didn't know you guys would have so much to say. Sorry, what were you?
But really the most important, well, maybe not the most, but one of the important factors there is knowing what range hood you're going to use.
Right.
What is the capacity of that range hood so that you could properly size your makeup air system for it,
Right.
to be able to balance that. Because if you have something that's really large, sucking out a lot of air, and you're not introducing very much, then you have an imbalance. But also vice versa, if you have a tiny range hood and a giant makeup air system, you will
Or open a window.
also create an imbalance.
That's right. And I think, speaking of exhaust air, we should talk about bathroom ventilation. That's where we create most of our humidity. And it's important that when we do create that humidity, bathing or showering, whatever, we get that humidity out of the house. Otherwise, the cooling equipment has to do it, or the dehumidification system has to do it. And it's just bad for that indoor air environment for it to stay at a higher humidity level. So when we do that, there's not a very easy way to do makeup air unless we have what's called ERV, energy recovery ventilator, that does that. So it's important that if we use standalone bathroom ventilation, we put it on a timer. So it shuts off in a very short period of time. It doesn't stay on. People forget that they're on, and you run that all day long, and it'll bring in a lot of outside air.
Oh, yeah.
Yeah,
I
that's
didn't
right.
think about that. Yeah. So let's skip to plumbing, the P of MEP. I'm going to save electrical because I think it kind of pairs nicely with AV. Just broadly, what considerations should people have? Plumbing layouts and thinking about hot water and all that.
I think that's the biggest question during the design phase is what kind of equipment are we going to need to heat the water, and where is it going to live? We discovered not too long ago that tankless water heaters really don't do well outside when you have extreme conditions seasonally. They have a mechanism, most of them have a mechanism built in that when the weather gets down below a certain temperature, they automatically sort of kick on intermittently to keep themselves from freezing up. But what we found is in our local area, when we get those cold temperatures, often we have power outages, which means that the water heaters can't protect themselves outside. We can put them inside, but ventilating them is sometimes a problem because they have to be propane or natural gas to be effective. You really can't find a very good electric tankless water heater. It's impossible to heat water that quickly electrically. But
without using lots of
Yeah.
electricity.
Yeah. So, and then there's a move to get away from using combustible gases on the inside of a house. So, again, we're moving away from tankless water heaters, and now we're doing heat pump water heaters as the best solution.
Mm-hmm.
And those generally require some amount of ventilation, but not for the same reasons. They can be located easily in a garage or other mechanical space, and perform really well.
Mm-hmm.
Yeah.
Mm-hmm.
Yeah, but I think similarly to the mechanical side, the distribution of that hot water is important as well. And to keep it being a high efficiency unit, you have to minimize the amount. So what we typically do is we do like a loop so that water kind of runs in a circular motion and intermittently keeps the water in that loop warm or hot.
Mm-hmm.
And then branched off of that, you have short runs to your fixtures so that you don't have to wait for a long time for hot water, but you're also not constantly running that machine, circulating the water all the time. Locating that either in a central location or in a corner where you're able to then hit that loop somewhere is a consideration as well.
Yeah. Yeah. And it kind of speaks to like, where are all of your plumbing fixtures in your house located? And
Yeah.
I mean, if you think about just visualizing that, you've got to be able to, like, the shorter the run, the easier it's going to be and the less material it's going to be. And
Right.
Another consideration that's maybe a bit more trivial is where your vent stacks exit the building.
uh-huh.
There's code requirements that dictate, where they have to go broadly, but you can make some decisions if maybe you put them, if you're penetrating the roof, maybe you're doing it on the backside of the roof,
Yeah.
so that as you approach the house, you don't see all these things
Yeah.
sticking out.
Ugly.
From a performance consideration, you want to keep them out of valleys or any sort of like places where they could be more vulnerable to leaking.
Right.
And if you can consolidate them so you have
Yeah.
fewer penetrations.
Yeah.
Personally, I don't like having them come out of the roof, so
I
I
know.
stick them
Me
out the
neither.
sidewall if I can. But that's not always an option.
Right.
Mm-hmm.
Plumbing is not as challenging as air conditioning, heating and cooling equipment for location and distribution. You have a lot more options with plumbing. Materials that we use are fairly straightforward and time proven. The efficiency of location is important to, as you said, make sure water gets to where it needs to be in a relatively short period of time. But I would say of the three considerations of MEP, plumbing is probably one of the most straightforward.
Mm-hmm.
Yeah.
What about, are there any considerations for like being able to turn off water or like thinking about future work or anything that we've learned from seeing mistakes?
Yeah, I think, one thing, these are very particular, but if you have, say, a wall-mounted faucet, for example, normally if you have a deck-mounted faucet underneath the sink, there are your shutoff valves and everything is accessible. But when you have a wall-mounted faucet, that's not the case. So you either have to be mindful about locating those and make them accessible nearby. Typically, if you're turning something off, it's not always an emergency, but sometimes it can be. So you don't want to have to run to the other side of the house. I think I designed or built a home years ago where I used a manifold system. And so there was a shutoff for each individual line, but that was in the attic. And so if there was an issue, I was going to have to run to the other side of the house, pull down the attic ladder, go up in there.
Yeah.
Thankfully, I had labeled them all, but be able
Yeah.
to shut off the right one. But I think that, you have to think about those things when you're using wall-mounted faucets, for example.
Yeah, that's a good example. Well, even just the planning, for instance, of choosing a wall-mounted faucet versus a deck-mounted. Often, we've talked about this fairly recently, like you have to know what all those materials are going to be and how far things need to stick out.
Yeah.
And it usually ends up being a little bit more sort of unknown or complex than like a countertop.
Right. Because a lot of the times when you place them, you don't have the answers to all the questions about how it's going to be finished and
Yeah.
the thickness of the back, the wall or the tile or whatever. So it's a challenge. We're also seeing more and more electronic valves in showers that have to be remotely located. Then you have to have access and some kind of concealment cavity for those, which is a consideration in design. Hopefully, before all the design decisions are made, the plumbing fixtures for the house have been selected so that the design professionals know about unique needs. Floor-mounted tub fillers, for example, have to be integrated into the concrete foundation before the concrete's even poured.
Yeah, absolutely.
I feel good about that. Anything else?
Well, one that's, I think, maybe just common basic knowledge, but doesn't always happen when you're, drawing up the framing. If you have a plumbing wall that's in a 2x4 wall versus a 2x6 wall, can cause a lot of problems and make it very difficult for the plumber, and also more susceptible to, being pierced by a screw or something like that. I mean, it's pretty standard practice to have at least a 2x6 wall where plumbing is located, but it's not always the case.
Yeah, that's a good point.
I'll say one last thing about plumbing is that in an ideal world, we would prefer that we don't put any plumbing pipes on outside walls.
Right.
Yeah.
There's a number of reasons for that, but if we can, try to locate plumbing fixtures, plumbing water lines, plumbing sewer lines on inside walls not exposed to the outside extreme temperature fluctuations.
Yeah.
Yeah.
Yeah. Good point.
Yeah, it's a consideration for us here, but parts of the country, you just flat out can't do it.
Right.
Yeah.
Right.
Even like as far north as Oklahoma, where I'm from, I feel like if you're living in an older house and you have plumbing on an outside wall, you always open your cabinet doors when it gets cold.
Oh, to let
to
the warm
like
air.
try to like
Yeah.
get some more warmth in that area. Yeah.
Yeah.
Okay, so let's go ahead and move to the E of MEP, which is electrical. I think on this one, I don't know if I have super specific questions. I do think we get a lot of questions. This is kind of jumping right to a specific, but we have a lot of questions about generators and batteries and solar and all of these other things. And I think it's because of a lot of weather events that we've experienced recently.
Yeah.
So that could be a jumping off point, just like big picture considerations.
Our power grid's not as reliable as it used to be. It's, our infrastructure's old, and I'm not sure that we have enough funds available to upgrade it as quickly as we'd like to. And so people can't rely on it like they could when it was new 40, 50, 60 years ago. And weather events, when they're extreme, have a tendency to take out electric lines that are above ground, suspended from poles. That's just something we're becoming more and more used to. So people look for alternative sources of power when those things happen. Generators, solar, battery backup are becoming more and more common in new homes today and retrofitted into older homes too. And those take quite a bit of spatial consideration. Where do they go? How do they interact with control and power distribution equipment? How are they regulated by the power authority? And so a lot of considerations there. They take up space, and they require certain code requirements for installation. Believe me, we could do a whole nother
Could.
podcast
Definitely.
session just on alternative energy sources.
Yeah. But, we should say that those, I think, particularly, it's important to be able to plan for those early, or at least future-proof for them and run the infrastructure ahead of time, because adding it after the fact, while we can absolutely do that, it's much more intrusive, and you don't necessarily end up with the aesthetic result that you would otherwise, because you have a lot of external conduit running around and things like that. So I think, if you even have an inkling that you're interested in those things, but maybe it's a phase 2, to be able to run conduit early in the original phase or run wiring in the original phase and have a plan for it.
Right. This is one of the areas that I think it's also important to have the right professional consultants involved during design, because it's not just integrating high voltage equipment together, but nowadays we're seeing that the low voltage control components are integrated with the high voltage distribution components so much that they all are becoming just sort of one system.
Yeah.
Lighting is a great example. That not only do we need to know where the light fixtures are going to go, what kind of light fixtures are going to be, what the job of each light fixture is as far as illuminating certain areas for certain tasks, but how they're going to be controlled and to what level they're going to be controlled is becoming more and more of it's not just a dimmer on the wall anymore.
Yeah.
It's controlled with a remote panel that tells it what intensity to come on at, which circuits to come on, and nowadays even what color temperature the light is going to come. So it's a very complex system that has to be thought through early in the design and integrated all along, where the switches go. And people often don't even think about that. They don't think how they're going to live there, where the furniture is going to be placed, how they need to turn those systems on as they enter a room and leave a room. All that has to be thought through during design.
Yeah, long gone are the days of the toggle switch and the incandescent bulb, right?
Right.
It's way more
so
complex.
It is so complex. And to think about, lighting has so many different roles. There's kind of like the general, or sometimes it's called architectural lighting, like the can lights, or and then there's task lighting for specific areas. There's also just the idea that lights are decorative, and I personally love light fixtures. It's like my favorite thing, I think, to pick. And so sometimes the architect will handle some of that. Sometimes there's a separate lighting designer. Sometimes our one of our trade partners, they have some in-house lighting designers. I'm wondering if there's anything we could help people gain an understanding of the range of options. Just thinking about just architectural lighting, for instance, and the features that you mentioned. There's a big range of price too for what you could spend.
Yeah.
Yeah, just to take one example. Some architectural lighting in the form of what we used to call can lighting, recessed lighting, if you will, which now is more than just can lighting, has a lot of different sizes and a lot of different electronic engineering that goes into them. You can spend $40 per fixture. You could spend $400 per fixture or more. And we've seen that in a lot of the projects that we've done, this broad range of options there. And there's a huge difference in what each of those lights can perform, how they can achieve those goals. But to know the answer to that, it takes more than just knowing where you want them. It takes knowing what exactly they're trying to achieve.
Yeah. What's when you say the 40 to 400, what are you getting? What things can you do with a $400 light that you can't do with a $40 light?
Great question.
One point for Daniel.
Great question. So, not to get too deep in the weeds, but
yeah, right. Just high level.
High level weeds.
Light that we use on the inside of our homes has several characteristics. It has the intensity of the light, right? We used to say, is it a 40-watt bulb? Is it a 60-watt bulb? Is it a 100-watt bulb? And that translated directly to an incandescent output of so many lumens.
Those were simpler times.
Right. Yeah.
When I felt like I kind of understood things.
Right. And the old incandescent bulb had what we call a color temperature, which is a complex graph of the light emitted relative to what the sun emits in degrees Kelvin. So warm incandescent light, which we used to use, is somewhere around 2,000 to 2,500 degree Kelvin color temperature. Very blue light, like the sun puts out, is more like a 6,000 degree Kelvin. So
Like a bright
and
white.
It's a very bright white light. So you can see that variation. Well, you can specify now the color temperature that you want in a given light, and the more expensive lights can vary in their color temperature at any given moment.
They're adjustable.
Yeah.
They're adjustable.
They can,
Yeah.
So changing color temperature is a very unique, nice feature to have in any given light fixture.
Yeah, it's kind of like if on the inexpensive end you have one light fixture, but on the high expensive end you have all the light fixtures in one light fixture.
That's right.
that's a good way to say it.
Probably the most valuable of all the characteristics of light fixtures, though, is the color rendition index. It's called a CRI, and it has to do with the ability of that light that's emitted to reflect off of any given surface accurately. Obviously, the sun is perfect. If you take a navy blue sweater and a black sweater out in the sun, it's very clear which is which. But if you go into a closet that has a low-grade light color rendition index, say, of 80%, then you can't really tell the difference between black and navy blue under that light. We look for a color rendition index of good quality fixtures above 90. And then you can generally tell the difference in colors indoors.
Interesting.
Yeah.
Something else that I find absolutely amazing and so cool is the warm dim feature. And that's as you dim a light, you're not just reducing the output, but you're changing the color temperature at the same time.
Right.
Oh.
And it's a much more pleasant way to dim a light.
Right.
Yeah.
But that's only achievable if you spend more money.
Right.
Yeah.
Our eyes and our circadian rhythm that we've evolved to enjoy over time lets us enjoy warmer light in the evening and at sunset and in the morning, and brighter, higher color temperature light during the daytime. That's just the way we're built. If we can do that indoors and replicate what we're used to from outdoors as the day cycles, then it makes the indoor living environment much more comfortable.
Yeah. Get that golden hour
The
lighting
golden-
inside.
Right.
Yeah.
You just trick yourself and have it all day.
Yeah. I love it. It's my favorite. Okay. Well, I think that might be a good transition to sort of the AV or control aspect of systems. There's a lot to say here. We've got lighting. We've got other automated things like shades, media, speakers and TVs. What do you guys think?
I think just to take us all the way back to the original sort of idea of the podcast and what are the considerations, and we've talked about spatial considerations. With lighting control, that usually sort of presents in the form of control panels. And those panels can be quite large, sometimes 5 feet by 2 feet wide. And so you need to plan for those, not only to be able to locate them in a wall and run all your wires to and from that location, but also be able to access it for service. As far as AV goes, typically those things are mounted on a rack, which is a tall metal rack that is on wheels, and it has all the components connected to that rack. And then all the wires that sort of are distributed throughout the house come to that rack. So you need room for the rack to be able to maneuver the rack around so you can service it as well. If you have shade controls, those also have control panels. And so you need an area to be able to put those. And, you can't just say for any of these things to put them in a closet, and that closet is also used for other things. It should be a dedicated closet because
That's a
you
good point.
can't, by code, you can't stack things in front of, electrical panels, for example. But also, some of these components put off quite a bit of heat. And so you have to be able to regulate the temperature and the airflow within that room as well. And if you've got it stacked full of boxes and other things, that's difficult to do.
Yeah.
But a consideration is, how are you going to sort of maintain the temperature in that room? How are you going to exhaust the hot air and bring in fresh, cool air? Because if it gets too warm in there, then those components don't work,
Yeah.
or they don't work very
Yeah.
well.
That's right.
Are there any like specifics to like where are good places or bad places to locate those types of closets?
Well, we've discovered that it's not a good idea to put low voltage equipment and wiring immediately adjacent to high voltage equipment and wiring. So we try to separate those two into different areas because as many wires as there are to feed all of the equipment and fixtures in a house, they obviously can run close to each other, and we all know that high voltage wire puts out a magnetic field that can interfere with low voltage wire signals. So we want to try to keep those separate.
Yeah. Okay.
We all know that now.
Yeah, we do now.
I'm sorry.
It's like physics with Tim. Well, what about though, like, and maybe there's not, I'm wondering, like, we said earlier for the water heater, for example, something centrally located or where you can kind of make a good loop with your plumbing fixtures. Are there any things like that maybe to think about?
I don't know. A consideration is the longer the run, the more wires you have, the more expensive
Yeah.
it gets.
Okay. That's good.
So for sure, I mean, centrally is usually better. I don't know. Those machines don't really make any noise, so you wouldn't have to worry about that. I mean, we've located some panels in bedrooms and bedroom closet or closets adjacent to bedrooms sometimes.
They're not attractive enough to justify putting them in the areas that sometimes it would be convenient to put them. Sub panels or sub circuit breaker panels that feed a particular area of the home, be nice for them to be located near the circuits that they feed. But finding a space for those is often hard. And we have to put them remotely, which means the wire sizes that we have to distribute to those areas has to be larger over longer distances.
So one thing that came up this morning, actually on a job site, I was meeting with Donnie and Carlos from Haas, one of the consultants that we use a lot. And we are adding security cameras for this house. And we started talking about locations and whether or not there was room in the wall outside to be able to tuck all of the components that are not the camera, and how they often run into the situation of not having room and having to add a box. I'm wondering, I think that's a really good example of like, if I don't have to, I don't really want to see the box tacked onto the outside.
Right.
Yeah.
Are there any other things that we can think of that if they're not planned from the beginning, we might have those types of situations?
Well, something that's somewhat related to that, but not exactly, is shade pockets.
Yeah, that's a good one.
If not that there's anything wrong with mounting the roller shades on the wall or in the window frame, but oftentimes you don't want to do that. It does feel tacked on, like you said earlier. But if you're creating a shade pocket that's up above the plane of the ceiling, that affects, the structural elements that are holding up the roof or the ceiling or whatever. So really, if you can plan for those before the framing happens, then you can integrate that into a truss package or into your regular framing. And knowing where they're going to go and how big they are, that's a pretty big consideration.
That's something that I think was like a big learning for me in residential architecture, thinking about like that's an interior design item that affects structural.
Yeah.
It's pretty impressive.
Yeah.
But it makes a big difference in the room if the shade is tucked up where you can't see it.
Yeah.
It is. It's obviously clear to most people that the more time you have to plan for those things, the more elegant the solutions can be. In your case, the project that you were on, it was a retrofit of equipment into an existing space, and that's really hard.
It is. Yeah. You got to get creative about it.
Yeah.
Kind of on the same topic, what about like the controls that the homeowner interacts with as far as kind of like buttons and switches and phones and what are kind of the range of options there?
Well, generally, low voltage controls can be more streamlined and smaller than high voltage controls. So if you can do the hard work electrically remotely in a closet, and you do just the signal work, the low voltage work locally, the more elegant the solution can be. And that's why a lot of people go toward low voltage control, because you have a lot more flexibility in the size and sleekness of the control mechanism.
Yeah, something that is very interesting, I think, with that is the days of, a bank of like 6 or 7 switches, because we have these open floor plans and all these different lighting options. Now you can do all of that in one little keypad, which I think is a huge game changer.
Oh, yeah.
Right?
It's amazing. I hate having to see those things.
Yeah. But also it's confusing too, because
That's true.
Even if you've lived there for a long time, you're always like, which one is it?
Yeah. I will say that we are also seeing options for us to do everything in low voltage. With LED lighting, which really is a low voltage lighting, we control it through high voltage signal, but if we can do everything through low voltage, then all of the wiring, all of the lighting, all of the switching can be low voltage, and we don't need a high voltage interface. I think we'll see more and more of that, so the costs will probably come down, and the electrical requirements will be less. But that will help designers and electricians achieve a lot of the things that clients are looking for with a more elegant solution, and not quite as expensive.
Yeah. To speak to the options, though, when it comes to control, nowadays we have so many different apps on our phone, so a lot of it can be done that way. Some clients prefer that. We have clients that say they don't want one system that does everything. They just want to have the apps on their phone, and they're happy with that. But there are control systems that sort of integrate all the different components into one interface. And sometimes that's looks like an iPad mounted on a wall somewhere, or it could be free floating.
Or your phone.
Or your phone, right. So those are some of the options, besides just having the actual hardware on the wall where you're pushing switches and buttons and stuff.
Right.
But even with the buttons and stuff, I mean, there's some beautiful options.
There's some nice buttons.
Yeah, some very nice sort of brass buttons and knobs, and it's you have so many more choices than you used to.
I think if you personally, and I'm not like a big fan of like the iPad looking thing, though like some people would totally disagree with me. That's just not, they love it.
Yeah.
But I love some of the newer switches where there's like, you get like a interaction with this button, and it feels nice and it looks nice.
Yeah. I think the button solution is obviously the more elegant. It takes clients familiarizing themselves with and programming each of those buttons to do a specific thing that they want it to do, and be willing to sort of live with that functionality over time. The larger screen interaction allows them to have more flexibility in determining exactly what they want any keystroke or button push to do, and within that process have some variability in what it does at that moment.
Yeah.
That's a really good way to describe sort of maybe if you're speaking to an AV consultant, to be able to communicate your priorities and like, what the trade-offs might be. Is it more important that it looks a certain way, or do you want that flexibility to be able to adjust?
Yeah.
I'm trying to think. I think that's like kind of a good overall. One last little thing I'd like to touch on is just for each of these things during design, if a client and their design team doesn't yet have a builder involved, let's say they're in schematic design and they enter into design development, they get, we're involved, we know how we work, and we work with our different subs. What are maybe some just examples of like the benefits from that pre-construction process whenever we're in design development working through these systems?
It's a hard question to answer. It's pretty big.
Like it's broad,
I would just say this. I would say that you are able to draw upon the expertise of these different individuals to create a sort of coherent project that functions the way that it should, and really not having to rely on one person to figure it all out.
Yeah.
Is really draw on the expertise and the knowledge of the individual people, even if it's not a builder, if it's these other consultants early on.
I want to put a shameless plug in for hire a builder now.
Yeah.
Early. So it's possible for a client to hire an architect having a piece of property that they want to improve or build on and go through the design process without any outside consultant, relying on the architect's expertise and experience to create something that works and is planned for well. It's possible. It's better to have design consultants, engineers, and interior designers, and landscape architects to speak to and help give input as to those aspects of the design. Optimally, it's best to have a builder who can then interact with the entire team. And here's the big bonus. Bring in all of those trade contractors that will also do the actual work.
Yeah, that's right.
And get their feedback as to the functionality, the constructability, the serviceability of all those ideas. And really, that's free. If you think about it, in the interest of participating and becoming a part of a project, our trade professionals would jump on the chance to have input
Yeah.
as to what they will ultimately have to install and integrate into those projects.
Yeah, that's absolutely right. And it gives them the input and the ability to end up doing it the way that they think is best.
Right.
And then the
Yeah,
product
and if
is
they're
better.
confident that they can install it well and that it's you're going to get a more refined solution.
Right.
I love that. And I think, the reason I asked that is like this morning, Donnie mentioned the only reason why we know how much room we need behind the camera in the wall is because we've done it.
Yeah.
And his I said, hey, we're talking about this afternoon. Do you have any recommendations? And he said, just get us involved as early as possible.
Yeah.
Yeah.
I love those guys.
Yeah. Me too.
Absolutely.
I love those guys.
I love those guys.
We say that a lot. Yeah. I don't know. Any closing thoughts?
No, I think that we've laid out a fairly comprehensive understanding of all those components that require spatial considerations and functional considerations. And there's a lot more to say, but certainly rely on the professionals to give you the best advice, and the chances of a successful project will be much higher.
Yeah.
Yeah.
I think, piggybacking on that, we've laid out lots of considerations, not nearly all of them, but lots of them. And that just sort of proves the point that there are so many things to consider that you need to bring in a whole team and really attack it from all angles.
Takes a
Right.
village.
Yeah. I like it.
That's it for another episode of Work in Process. Thanks for listening. If you've got a question, a topic suggestion, or want to start a project with us, send an email to hello@risingerbuild.com.
You can also find us on Instagram at risingerbuild_ATX or on YouTube by searching Risinger Build. We'd love to hear from you.